Welcome to aminacademy.com. In electrical engineering, let us discuss about energy stored in capacitor. Charging of a capacitor always involves some expenditure of energy by the charging agency. This energy is stored up in the electrostatic field set up in the dielectric medium. On discharging the capacitor, the field collapses and the stored energy is released. To begin with, when the capacitor is uncharged, little work is done on transferring from one plate to another. But further installment of charge have to be carried against the repulsive force due to the charge already collected on the capacitor plates. Let us find the energy spent in charging a capacitor of capacitance C to the voltage V. Now let first PD across the plates PD across the plates equal V, and charge is dq, then work done equal W equal V dq. Now Q equal C into V. Therefore dq equal C dV. From that, by substituting this dq as C dV, we can write dW equal CV dV. Now this is a dW, then we have to find total work done. Total work done is integrating 0 to V dW, that is dW is CV dV. Take out the constants C and integrating V dV is V squared by 2, which is equal, by giving the values 0 to V the limits, we have C V squared by 2. Therefore work done is half CV square. That means energy stored. Now this is written this way also. Look at here, this half CV square is equal half QV, because this Q is equal to Q by V are substituting, and that we get half QV. Further, it is equal Q squared by 2C. These are the three expressions for the energy stored in capacitor in joules. Now, suppose, note this point. The plate area, each plate area equal to A meter square, and thickness of dielectric medium, thickness of dielectric equal D meter. Therefore volume equal volume of dielectric medium is AD meter cube. Therefore you can say stored energy per volume of dielectric, unit volume of dielectric equal half CV squared by AD, that is joules per meter cube. Now these are the expression for stored energy per volume of dielectric medium. Now let us do example problem regarding this concept. A parallel plate capacitor is charged 100 coulomb. 100 microcoulomb 100 microcoulomb and at 180 voltage. It is then connected to another capacitor of capacitance 4 times the capacitance of the first capacitor. Find the loss of energy. The capacitor is connected in with first capacitor or with parallel. Then we can write Q, given the things, Q equal 100 microcoulomb, V equal 150 volts. Now C1, the first case, the parallel plate capacitor of 100 microcoulomb and 180 volt is connected first charge through the ground. Capacitance equal 100 by 100 volt by 150. Now 100 C equal Q by V, C equal to Q by V, 100 coulomb, microcoulomb by 150, which is equal 2 by 3 microcoulomb. Because it's micro here, microcoulomb, that is equal 0.67 microcoulomb. Then energy stored in first case, E1 equal half CV square, that is half into C is 0.67, voltage is 150 square, which gives 7.5575 into 10 raised to minus 3 joules. After simplification, this gives this much joules, E1. Now the total energy is, in first case, total energy is the same things, because second, it is not connected with another capacitor in first case. Joules. The second case, look at here, in second case, that is 4 times the capacitance of the original capacitor is connected in parallel. So we have now connected in series, that is connected series here. Here second case, the voltage is second case voltage, look at here, the voltage is total and total charge is 100 coulomb over, that is look at here, 2 by 3 plus 4 times 2 by 3. Actually this connected with parallel, not series. Second case, look at here, because already 2 by 3 is capacitance and 4 times that original capacitor is connected with parallel. So we have This is 100 over 5 into 2 by 3 gives is 45 volts. 45 volts. Now energy, then E1 is half into here this 4 times 2 by 3 is 8 by 3 of CV that is in 10 power minus 6 micro and 45 volts 45 volts that square which gives 2700 into 10 power of minus 6, which is further equal, you can write 2.7 into 10 power minus 3 joules. Therefore, loss of energy you have to subtract from this first case energy 7.557 y minus 2.7 into 10 power minus 3 joules, which is equal 4.8575 into 10 power minus 3 joules. That much energy is lost because of we are joining a capacitor parallel to that original capacitor. Next problem. A parallel plate air capacitor is charged to 150 volts. Its plate is 2.5 mm and the area of each of its plate is 180 centimeters squared. Calculate the amount of the increase or decrease of stored energy when plate separation is reduced to 1.5 mm at a constant voltage at constant charge. Here, parallel plate capacity is given, voltage is given, and plate area and separation is given. Now, V equal voltage equal to 150 volts and D, the separation of the plate is 2.5 mm, which is equal to 0.5 mm minus 3 meters, and plate area equal 180 into 10 power of minus 4 meter square because centimeter square is given. Now capacitor C1 with epsilon 0 air capacitor over separation D, which is equal then by using this values, that is here epsilon 0 is 8.854 into 10 raised to minus 12 into A is 180 into 10 power minus 4 over separation is D is given as 2.5 into 10 power minus 3 meter, which by calculation which gives 63.75 approximate of 10 power minus 12 farad, which can write as 63.75 picofarad because 10 power of minus 12 is pico. Now here the first case, calculate the calculate and account for the increase or decrease stored energy when plate is separated, reduced. The plate separation is reduced means it is become more capacitance will come. Now the second case, C2. Look at here, the C2 is epsilon A by D. Here epsilon 0 is 8.854 into 10 raised to minus 12 into A is seam plate area, that is 180 into 10 power minus 4 meter square over D is 1.5. It's reduced as 1.5 from 2.5. It becomes 1.5 mm minus 3 meter. Now by new calculation it gives 10625 into 10 power minus 12 farad is equal 106 into 25 picofarad. Here, due to reduction of the separation of the plate, this charge is increased. Charge is increased. Here, previously the charge is 63.75 picofarad. Now 106 into 106.25 picofarad. This charge is increased. Here, next part of the question. At constant voltage and constant charge, we have to find the stored and calculate the account for increase and decrease stored energy. Here we are finding farad changing. Now delta E. First case now charge is increased. Now we have to get it there to situation. First one, when voltage is constant. When voltage is constant, look at here, delta E stored energy equal half C2 V square minus half C1 V square. Voltage is constant means we are using common V, which is equal half into V is 150 voltage, V equal to 150 into C2. C2 is 106.25 minus 63.75 into 10 raised to minus 12 microfarad. So which gives 478125 478,125 into 10 power minus 12 joules, which gives 47.8125 into 10 raised to minus 8 joules. Now this is the first case when voltage is constant. Next one, when charge is constant, when second case, when at constant voltage, at constant charge, at constant charge, at constant charge. Here E equal E1 equal half Q square, charge is constant, C1, and E2 equal half Q squared by C2. Now delta E, potential energy, that is stored energy change in stored energy is half C, half Q squared is common, 1 by C1 minus 1 by C1 minus 1 by C2, which is equal half Q squared 1 over 63.75 minus 1 over 106.25 into 10 power minus 12. Now we are substituting Q equal to CV, C1 V1 or C2 V2. Both are same here. Q is constant here. Therefore, half into C is 63.75 into 10 power minus 12 into V is 150 volts. Both are square. Into here this calculation, that is 1 over 63.75 minus 1 over 106.25 gives 0.0157 minus 0.00941, which gives the final calculation gives which 28.76 into 10 power minus 8 joules. Here there is a decrease in the stored energy. The reason is there is decrease in stored energy. Here before the stored energy is 47.8125. Here 28 point stored energy is 28.7. Note here there is decrease in stored energy. Decrease in stored energy. The reason is that charge remaining constant, because charge remain constant. Then voltage must fall with the consequent decrease in stored energy. So far we have discussed about stored energy in capacitor as well as regarding solving problems. We have done. Please subscribe our YouTube channel.